Hi everyone, Quiveen here from the comfort of my kitchen. In today's video, we are going to be looking at a meteor shower that is coming up in the month of December. So here we are, just coming up to 8 o'clock and Gemini is already in the sky. We're looking for the Geminids, the Geminid meteor shower, and the radiant is already up. We can see it just there in the head of Gemini. If we push a little bit later, we can see that there are other meteor showers that are going on in December, but the Geminids are really the ones that we're interested in. Having a look at a few of these other ones, this one here, the comet-Bernicids or comet-Bernicids, the hair of Bernice, the comets from the hair of Bernice, and I'm not joking, just as proof. Here's the constellations, and we can see that the radiant of the comet-Bernicids is pretty far from the constellation of Comet Bernice, this lock of hair here. Of course, this is a good example as well of these there was a meteor, always nice to see. These meteor shower radiants being named after the constellation that they come from. They're a little bit off, we can see some of them here, especially the comet-Bernicids. But they're peaking on the 16th of December, a maximum zenith hourly rate of 3, so not a particularly big meteor shower. The December Leonis Minorids are also a pretty small shower. They're peaking on the 20th of December. We can see there a zenith hourly max of 5, which of course isn't much either. The Alpha Hydrids, we can see they're peaking on the 9th of December, so a little bit earlier than the date we're looking at, up to 7, which isn't terrible, but again, looking back on meteor showers like the Leonids and the Perseids with rates of, 20-ish, these meteor showers are pretty small. We can see the December Monoceratids, and we can see it's there in Monoceros, the unicorn. That's peaking on the 9th of December. Again, zenith hourly rate of 3, so not particularly good. The Antihelion is there as always. It drifts across the sky. It's always directly opposite the sun. It's directly behind the Earth compared to the sun, so it's going to change where it is in the sky, but roughly passing through the zodiac or the zodiacal constellations. So we can see a good selection of them here. We've got Taurus, Gemini, Cancer, Leo, and Virgo all in a row. If we move through time, we'll see the Antihelion moving through there, the exact opposite position to where we would be seeing the sun during the day. And we can see that all of these radiants drift around because the Earth is moving through these streams of material. So on different nights, we've turned a little bit more, and that's caused them to hit the atmosphere a little bit differently. Oh, there's another meteor. Nice to see. Rare, definitely, to see 2 of them in one video. But here we are, the Geminids peaking on the 14th of December. We'll move around and try to find the exact peak as well. But we can see the zenith hourly rate here, the max of 120. So the Geminids are generally regarded as the best meteor shower. I am a fan personally of the Perseids, but the Geminids are the one that is widely recorded as the best. So we can see here pushing up to the morning of the 4th that we're getting up to probably the most we're going to get. Yeah, I think it just about hit 120 there. The absolute peak of the shower at just 7:30 in the morning. So really watching this meteor shower from sunset on the, from a little bit after sunset on the 13th through to the morning of the 14th seems to be best. So we can see that the radiant there pretty low in the sky. It's coming up there a little after 7 o'clock. So the sky will have already been dark, or would be at least fully dark at this time. So we can see it's there at a rate of 74. As we get later in the night, the rate climbs and the radiant gets higher in the sky. The closer to the zenith the radiant is, really the better. So we can see here, just as the Geminids are right above the south, the highest point that they're going to reach, the zenith hourly rate is 99, and we're getting 39 for the local hourly rate. But that is, of course, limited by light pollution as well. With all meteor showers, it's better to head out to the countryside. That's where you'll get the optimum view. So we can see here now, pushed out to the countryside, the local hourly rate is 94. The current zenith hourly rate, what it would be if this was actually at the zenith, is 99. So we're pretty close. And the max then is 120, which comes up later in the morning. But even though the rate continues to increase, we can see if it was at the zenith, we'd be getting 118, but it's getting lower in the sky, so that's going to cause us to miss a few meteors. They're going to be visible to people below this horizon. That brings it down to 71, and of course then the sun starts coming up, and that's going to make the meteors much harder to see. So the Geminids is considered one of the best meteor showers. It has these zenith hourly rates of 100, 120 pretty much every year, and it is regular in that way. It doesn't seem to produce meteor storms like the Leonids do, where there's hundreds of thousands of meteors, but they are regularly very productive. It happens in December, very close to the shortest day of the year, so we have a nice long dark night to observe the Geminids, and hopefully here in Ireland, at least this far into the northern hemisphere, it is winter, so there's a good chance that it will be a cold, clear night. If there is a frost, then there's a good chance there will be hardly any clouds in the sky. There won't be much available humidity because everything will be frozen, and that makes it much easier to see meteors as well. A very clear night sky with lower humidity, which tends to happen when it's very cold here in Ireland. Otherwise, the humidity can be quite high. Now, we can see here as well, the parent body of the Geminids is a minor planet, 3,200 Phaethon, or Phaethon. This, and there was another meteor there, so there's definitely quite a few popping up in this particular video, which is appropriate. This meteor shower is caused by what could be considered an asteroid. It doesn't really seem to be a comet. It at least doesn't behave like a comet. It doesn't produce a tail when it goes around the sun. It does have a similar orbit to a comet, but it does seem to be a ball of rock, and little bits of rock falling off this object are what create the Geminid meteor shower. This asteroid comet object is a little bit hard to define, so it often gets called a rock comet. And it does have a pretty Phaethon, a pretty metal name, which is appropriate for a rock comet. But we'll see if we can find it in the image or the search here. So there's the asteroid way out in space at the moment, magnitude 18, discovered in 1983. So this is a reasonably recent discovery. It's only, in the 80s is when we found out that this comet was, or this rocky object, this asteroid, it's here listed as an asteroid, that this object was the parent body of the Geminids. It was something that was only figured out comparatively recently. So we can see there, it's not even particularly big, 6 kilometers across, so much smaller than some other comets. We will need to move through a fair bit of time to get it back to its perihelion, because it does have a longer orbit. It is a long orbit, quite similar to the orbit that a comet would have. So we would have to move through quite a lot of time. So what we'll do is we'll head out to the Solar System Observer, and we'll take a look down on the comet and see if we can bring it around to the its perihelion, whenever that is, and see exactly how comet-like this orbit is. So there are, of course, as always, a lot of objects to search through. Here we go. And we will turn on the orbits for the planets, because I do think that makes it a little bit easier to see exactly where everything is, to see where the... Whoa. We don't need to see the orbit of every single comet and asteroid, but here we go. So this is where the asteroid Phaethon is currently moving through time. Of course, moving through days, it's going to move pretty slowly. These things do take a while to move around. So we'll come down here and we'll see, yeah, years do seem to be a little bit better. So we can see it there coming into its perihelion. So we can see it there, yeah, inside Earth's orbit, just crossing Venus's orbit there in December. Moving back to November, we can see that it's inside Mercury's orbit. Now we should probably start moving by days, because the motion of the comet is so much quicker when it's at perihelion compared to when it's at aphelion, when it's further out from the sun. So we can see it there making its perihelion sometime around the 19th of the 10th, 2023. So definitely quite close to the sun there. I don't think it's going to... Yeah, it's giving our distance from the sun 0.164 AU. Very close. So now that we are able to move by days, we'll go through days again. So that was when it came in towards the sun. So it came in towards the solar system, and we'll see it crossing on its way in towards the solar system, crossing Earth's orbit just there, the 13th of the 9th. And if we follow it around again, it took, we had to jump through a couple of years to get the comet from almost out by Jupiter's orbit back into the inner solar system. And we only have to go through a couple of days to see this asteroid come all the way around the sun, from crossing Earth's orbit on one side to crossing Earth's orbit on the other. So it looks here, we just tipped into 2024, it looks here like it's crossing Earth's orbit pretty close to late December, around the 29th, even though the meteor shower caused by this asteroid is peaking on the 13th and 14th. But this is actually very up to date. The orbital elements are for 2025, and we are looking back years here, so that is going to make a difference. And then we can see the comet just making its way out to the outer solar system. We jumped quite a bit of time there. We'll zoom out a little bit and just see if we can bring it to aphelion. So we'll zoom out a little bit. We can see the orbits of the other planets. We'll come back up. There we go. 2025. Okay, so it does look like its aphelion is not too far out. It looks like it's actually quite close to its aphelion now. Yeah, just earlier this year, by the looks of it, the object is out at 2.37 AU there. We'll see if we can get that number to go up. Nope, that's down in November. It looks like it's actually coming up to its aphelion just about in December, just about the time that the meteor shower that it generates is peaking. Yeah, so we got up to 2.403, yeah, just 2.403 AU from the sun. Yeah, just around the peak of the Geminids. So that's interesting. So we can see that this comet-like object, it took from 2023 till 2025 to get out here. It will presumably take about another 2 years for it to get back in, so it seems to have a period of about 4 years. I don't know if any of that detail is being given there, but that's okay. This strange object, this rock-like comet, is the parent body to the Geminid meteor shower, and we can see it there looping around in its pretty short but also quite comet-like orbit, even though it is much shorter than the orbits we might be used to for true comets, because this, you know, doesn't actually seem to be a comet. It is just some object that gives rise to the Geminid meteor shower. So that is comet or asteroid 3200 Phaethon. It seemed like an appropriate object to cover, an interesting object to cover, given that the Geminid meteor shower is coming up this month, and I will mention it again when we get a little bit later into December. So I hope you found that interesting. I hope that you enjoyed this video. If you did, please do like it, and if you like this kind of content, then please subscribe to my YouTube channel. If you'd like to read this information, you can do so on my website, queevinscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.